Our main speaker this afternoon is Ray Prober. Ray is president of Accurate Die Design. He's worked in the tool and die industry for more than 30 years, starting as a tool and die maker, becoming tool department manager, and then vice president of a metal stamping company. His company sells, trains, and supports LogoPress 3 and Forming Technologies, Inc. software. Ray's been using SolidWorks and has been a certified SolidWorks professional since 2002. Now, following Ray's demonstration of the software, we'll present a brief case study on TrueLine Inc., a manufacturer of custom-built progressive dies, contract stampings, and injection molded parts based in La Crosse, Wisconsin. On the line after Ray's done with his demo will be two company executives from TrueLine who will describe their experience having switched from another 3D design software to LogoPress 3. All right, so we'll welcome now Ray Prober.
Thank you very much, Brad. Hi, everyone. Okay, let's start with a quick PowerPoint presentation. I'm going to go through this relatively quickly because I've got a lot to show you in a short amount of time. So forgive me for talking fast, but let us know if you can hear okay. LogoPress, one of the very key points is that for 22 years, they're 100% dedicated to die design and flattening software. They have no other business. They don't do mold software. They don't do CAD software. They don't do CAM software. The development started 25 years ago in 1986 by the D'Amico Group, a 30 million euro per year company that makes press equipment and stuff. LogoPress company was formed in 1989 when the product was ready for market. They spun off that company. Other interesting LogoPress 3 facts, it's built on the strength of SolidWorks and its 1 million user base. All LogoPress 3 products are SolidWorks Gold certified. It's sold in 30 countries around the world. Back to Gold certification, we're one of 2 companies in the world that has 3 Gold certified products. This one I found interesting. One LogoPress 3 customer has designed a die with over 900 stations. I just found out about that. 4 different dies, I guess, in line. Note that LogoPress 3 works with all kinds of parts. We do linear bend parts, we do funky automotive parts, electronic parts, round parts, etc. More important notes about LogoPress, they've been developing die design software longer than any other 3D die design developer in the world. It's the only company developing 3D die design software and flattening software that does this exclusively. They have over 1,200 seats worldwide, not including those in education. And this one is very important as well. 634 customer requests have been implemented into the software, so we really listen to our customers. And from a user standpoint, one customer said, I can design small dies using LogoPress 3 twice as fast as I can using SolidWorks alone. With big dies, that difference isn't quite as high as that just because there's more thinking involved with big dies. We sure like it. It's everything you claim to be. And a recent one a few months ago, LogoPress 3 has proven to be an asset to our business. Not only the software, but the support from Accurate Die Design goes beyond the call of duty. They're not just another software supplier, but more like a business partner. So we sure appreciate that. And some of our customers. Some of this stuff, a lot of what you can see on our website is designed by us in the past. We really do very little design anymore. Our business is virtually all software sales and support. And training, of course. Over 50 years of combined experience here at Accurate Die Design, both in die design and tool and die making. Some contact information. And be sure afterwards to check out our website for high-def videos related to LogoPress 3 products. So without further ado, let's get started. I'm going to start with some unbending, and I will start with something I like to call the worst model ever. It's just a dumb parasolid file that I just imported, and I use a lot of keyboard shortcuts, so that's how I save. So you won't see me going for icons too often. This part is interesting in that it's got. Whoops, double click. This part is interesting in that it's got material thickness that's not parallel. So this was a huge lead frame that we cut this small piece of it out. So I've saved it already, so I'm going to go to unbending by steps. And we've got different material thickness in the corners. There's dirt in the model, so to speak, and sharp corners, thinner material, etc. So let's start with these bends. And I'm actually going to turn my stopwatch on, and this one. Very robust. We can unbend a lot of things that SolidWorks sheet metal can't at all. And SolidWorks sheet metal is a great product, very, good product. It's included with the software, of course. This one we got a radius running into a radius, but you just can't expect SolidWorks to be able to do everything, of course. And the other big difference between SolidWorks sheet metal and us, we're automatically determining the K factor for every bend that we unbend. So let's close this, and I'll just go ahead and save it. And then the complex box, you can see this on our website. I just wanted to show you one thing quickly on it. And show my edges and save it. And this is based on a real part from one of our customers, unbending by steps, and we'll click here. And no worries, you're going to find that this doesn't work the first time around. There's some editing we have to do. But we're going to put some spring back and overbend on this. If I look at this, if I go to measure this radius, actually let me close that. If I go to measure this radius, by clicking here, we can see it's a 3 millimeter radius, 1/18. So if we go to unbending by steps and click here, it tells us down here that it's a 1/18 radius, and that's a 90-degree angle. And we're going to apply a spring back, and I'm going to change this and make it a 10-degree angle. And see this 1/18 radius? When I hit tab, it recalculated that radius to 103 thousandths. And I'll hit OK, and that's what we get. So as I said, it's not the result that we want, so we will simply edit this sketch and drag this line over and hit OK. Still not exactly what we want, then we edit this. When we have a gusset in there, we've got to do a little bit of extra work, but again, I think you'll agree that it's dramatically less work than you would have to do with SolidWorks. And again, we just remodel that part with a 103 radius, so when it relaxes, it's going to be the correct size. So that's just a quick sample of LogoPress re-unbending. Again, we're going to automatically determine the K factor for you, so you don't have to guess it if it's a quarter or a third or whatever. Now we're going to do some LogoPress 3 flattening. And save that. And save. Okay, and blank for form part. Click here. We got quite a number of options. And we'll change this setting to a normal mesh size and compute. So what you're looking at right now, you saw the folder say LogoPress 3F. The F stands for flattening. LogoPress 3F includes both unbending software and a product that we call LogoPress 3 Blank. So what you're looking at here is LogoPress 3 Blank in action. So we just solved the part. We calculated the stress, the strain, the thickness, the thinning. So here's the mesh that we put on the part, and the strain, stress, etc. So let's go back to strain. We can adjust the scale to look at, so we've got different colors, and then we'll go down and animate that. And we can slow down the animation. So that was LogoPress 3 Blank. And there are a lot of other examples on our website. And there's the flat blank. So very fast, very accurate. And now we're ready to go into our demonstration for die design. So here's the part that we're going to demonstrate today. It's, as you can see, a dumb parasolid file. Let's save the part. And show our shaded edges. And I talk a lot, so I'm going to try not to because we don't have time for it. So I'm not going to explain the technical aspects of this. I'm just going to start doing it. Finished and relaxed. So this station, we're just naming what this station looks like. So before it's relaxed, we're going to apply overbend to this because we know it's going to spring back with such a large radius. So we go to unbending by steps, click here, go down and apply spring back. It's 800 thousandths right now. If I overbend that by 10 degrees and hit tab, it recalculates to 650 and hit OK and OK. And there's that station. Insert a station mark to name that station. And we call it overbend. And of course, you can call it whatever you want. And so we're working from the end of the die to the beginning of the die. So if that's the case, before it's overbent, of course, it's not. So we go to unbending by steps, and we unbend it. So that's what the station before looks like. And so now we have to name the station before. And for that station, we're forming down 2 times. So we insert a station mark and name it form down to X. And this is all live, of course. I'm real. Forming down 2 times, so before we form down 2 times, it's not. So we go to unbending by steps, and we'll unbend that. And come to this area, and many of you know what a moved center partial unbend is. That's what we're going to do here. Not a full unbending, but a moved center partial unbend. It's the best way to do the vast majority of partial unbending. And select these 2 options, and watch the center line of our bend move out. And OK. And so now this station is done. So we insert a station mark. And for this one, what are we doing? We're coining the 3D area and wipe down 45-degree tab. So just like when you were drawing on the board, this is how you remember what's going on. You're naming the stations. And so the next thing we'll do is unbending by steps, and we'll get rid of that bend. And hit OK. And then we are also going to get rid of that coin. Okay, and this station, insert a station mark, is called Form 3D Area. So, of course, before that area is formed, it's not. So we go normal to, and we're going to cut that off so that we can do the flat blank prediction on it. And again, I use a lot of keyboard shortcuts. I think they're very fast. A lot of people liked it with AutoCAD or CAD key back in the 2D days. And that's all great with SolidWorks and LogoPress as well. Okay, so we go back to LogoPress 3 blank, and I select this area, and I hit compute. Again, lots of options. Certainly don't have time to cover nearly all of them. So there's my blank that it just calculated. And again, it calculated the stress and strain at the same time. We can animate it in no time. Okay, so now we will edit this. And again, if you re-watch this video, you'll understand what we're doing. We really need to cut that off now, and we edit this feature to merge the results. Okay, and so there we have that station. Insert a station mark. And what is this station called? What is the last thing we can see being done here? And we don't worry about the pierced holes that are at die level. We'll manage those automatically. So this one is called emboss gusset. And then, of course, and the gusset is on both sides of the material. So before, in the station before, that gusset isn't there. So I get rid of the gusset. And the final station mark is, of course, flat. Again, we don't worry about the holes. And we save that. Let's rebuild it. And a great tool in LogoPress 3 that I used to forget about teaching, but it's just too nice to forget about, is show or hide bodies. And one of our international customers turned us on to doing this. It's just a great idea. Here's the first station, we're embossing the gusset, then we form the 3D area, then we coin it and wipe down the flange, and we can turn on and off stations as we wish. So if we want to see how this station interacts with that station, it's great for teaching apprentices or young people about what a move, center, partial, and bend is and why we do it. It's a very, very visual tool, of course. And overbend and finish. So again, we can demonstrate the overbend here and why we're doing it. And let's hide all the imported bodies and show that body and save. Okay, and let's not close that. Let's go to part preparation before strip starting. Nope, don't need to, just did. And we're obviously automating a bunch of stuff here. And this is asking for the part we want as origin. And switch this to 180 degrees and hit OK. And we just did all the stuff that you can see in this folder, and we imported a bunch of configurations. I won't get into it, but great, great performance enhancing thing, this part preparation before strip starting. So I save that, and then I go to create or edit a strip layout. And let's see, I'm going to hit the configuration at the station button. And we're going to add three idles after the embossed gusset. And we're going to add one more station after the relaxed station. And so we've got a total of 11 stations. We're going to call this the strip assembly. And I call everything strip assembly. It's differentiated by the job number. So everybody has job numbers or project numbers or something. So this, now we have a job number getting added to every single component that goes into the die. Great, great feature. And we just created an assembly. We're putting 2 times material between the parts and 1 times material front and back to the parts. So there's our assembly. And now we will come here. Let's see, we can collapse this. We don't need it. And let's look at, we've got 25.4% material loss, and we can look at that in the first couple of stations. But let's try some part nesting and see how much we can gain. 25.4% loss, and when we nest the parts, 23.2, it's not worth having the blanks out of position, so let's change that back to 0. And next thing we're going to do is the difference, the space between the parts, I want that punch to be at least 200 thousandths wide. But what I really need to control is the progression. So let's change that to 2 1/4, and this number updates. And let's change the width to 6 inches. And let's change, or show the, display the configuration name. Again, I won't get too deep into it. And then we'll zoom out a little bit so you can see what's happening when we apply. And we just updated the strip width and progression. And now we're ready to start adding some punches. So we click on punch, and let's see, actually before, let's first do the automatic punches. I said we don't manage the holes inside the strip. So we're going to do that using this tool. Let's create the internal cuts automatically in station 3, and the cylindrical ones let's do in station 2, and hit OK to that. And this is showing the center of tonnage in the die. And then once we've got that done, let's add a shoulder to that. We've got lots of different kinds of shoulders. Let's add a shoulder with a T and all fillets. So there. And OK to that. Oops, I didn't mean to hit no there. I exited strip layout. So I go back in, and I add another punch. This is a cool feature. By adding that punch, it just zoomed in normal to, created the punch, put me into sketch mode, so I'm ready to start drawing. It's doing a lot more work than it would appear. I guess you just don't realize until you start to use it how much work it's doing. Then we've got a great command down here called Search the Punch Outline. These commands are also up on the LogoPress 3 toolbar, or on the Command Manager tab of LogoPress 3. So there's one punch, and I'm not going to bother dimensioning that one. This isn't a webinar about dimensioning, so we're going to be pretty rough about that part. Add another cutting punch, creates the punch, zooms me normal to, puts me into sketch mode. And start a rectangle and go from here to here, about, and we'll pull that down a little. And search the punch outline. I'll do it down here this time. And I'll dimension this right away as long as it's in view. And I put the dimension on, and then I hit the delete key. So I was just positioning that line, and then I'm going to dimension to here. And I will dimension here right away, 0.5. And this one, we make this the same, 0.5. This is my preferred way of designing a die like this. And this one we'll make 0.5. And let's zoom in on this area. And let's put some LogoPress 3 punch mismatches on. This is my preferred mismatch for a standard bypass mismatch like this. But we also have the loop, which is probably more popular. Saves a lot of time. And my very favorite mismatch, because of how much time it is, how much time it saves, I should say. For those of you that know me, I say I'm very lazy. I want the software to do the work. I don't have time to do this. And now we've got a fully defined sketch. And zoom previous. And let's now do some fillets and 10,000. Okay. That punch is fully defined. And now if we zoom previous to that and zoom with a window into the mismatch area up here, you can see how the mismatch is interacting. Okay, and let's apply those cuts. Oops, wrong keyboard shortcut. And let's see, let's add a cutting punch now. Or cut-off punch, I should say, I'm sorry. Zooms as normal to, creates the punch, and search the punch outline, and hit OK. Now we can take that punch, and we can move it down with these arrows. We can move it to another station, or we can simply grab it while holding the Alt key down and move it that way. And we won't apply that. Well, yeah, let's go ahead and apply that one. And then we'll do some form punches. And the formed area on the strip that I want to do first is over here. Like so. And that's going to be a 3D punch. And that right there was my favorite ever LogoPress 3 command. I said I'm not going to dimension too much. And there's that punch. Another form punch. We'll put that one over here. I guess we'll do this 3D form punch now. this one is going to be a 3D punch cavity. And click this button to zoom normal to, zoom into this area, and right-click and select tangency. Oops, missed it. Right-click, select tangency, and offset entities. Reverse the direction of the offset, change it to 30 thousandths, and hit OK. And we will draw a line from here to here. We'll trim this. We'll dimension this. Again, keyboard shortcuts are where it's at. Whoops, I forgot. I need a constraint here first. A parallel constraint. And now I can dimension. We'll make that 0.7. I want to fall into my mismatch, or my surface area. And I don't always have to do that. On this particular one, I do. And again, I won't get into it. And we'll get back to that punch later. And let's save. And another form punch. And we can do cam form punches as well. Actually, let's do this one over here. Coin punch. And need to change that to that. Zooms normal to, zooms us in. That zooming normal to and zooming in is just clearly a time saver. And keep the circle. And OK to that. And now let's do this simple punch. Set that one first. And for this one, we pick that and that. And now this one, we don't want a radius overlapping, so we pick the third one. And now here's where I'm going to draw a rotated rectangle. And here's where, for those that are watching, especially that are LogoPress 3 users, don't dimension this way. It's not the right way. I'm just doing it because it's fast for the sake of time. So do as I say, not as I do. OK. Add another form punch. And this one will be here. Same type of punch. Okay, in there. I love that. Zooms me normal to. Again, we would obviously dimension these, although if we're just doing a strip layout, we wouldn't, right? Like so. And add another. And let's see, this one will be over here. And this one we're going to be a coining punch, for radius coining punch. So we'll automatically coin, or the punch will get automatically created to do the coining, I should say. And I won't show it to you, but I don't have time to zoom in. But there it created that coining punch. Actually, it didn't, and I don't know why. I'm going to cancel that. And I'm going to do it again. Hit the wrong button. Okay. I'll try that one more time. Punch, coin punch, slow down. Formed area on the strip is here and here. Ah, that's what I screwed up, I think. And rotated rectangle. Make that collinear. Excuse me. Huh. Sorry about that. Not sure why that one's not working out. We'll have to get back to you on that one. Let's add another coining punch. And the formed area on the strip on this one is back here. And for this one, we will do a radius coining punch with radius overlapping. And rectangle right here. Hit OK. Wow, that's a problem. So I'm going to cancel this, and I'm going to apply what we've got here so far. Because something is messed up in its brain, I think. Control save, and I'm going to close this assembly, and then I'm going to just reopen it. So this is good, right? I mean, you have to see what things don't work too. Okay, LogoPress 3, create, edit, strip layout, punch, form punch, and the formed area on the strip is back here. It's going to be a radius overlapping punch. That's better. And this one we've obviously got a problem, so I'm actually going to take this punch and throw it in the garbage and try it one more time. Form punch, formed area on the strip is here and here, and rotated rectangle. Collinear, and OK. That looks better, doesn't it? That's very strange. So it just had something in its memory it didn't like. And again, that punch is actually coining. OK, so let's see. I think we've covered all the punches, the form punches, etc. And OK. Now, one postpone action, yes, please apply it. And now this, I'm not going to explain it, but here we're going to calculate all the forces. So it takes a little bit longer to exit. But we're calculating a bunch of stuff. And we're also, if we zoom with a window, we've named the stations. Like here we've calculated and computed. We did an estimate and then actually computed the forming force. And then here, this one is very nice. If we zoom in over here, we just did all of that. Okay, so let's close that. And save all, and close that, and close that. And actually, I probably should leave the strip assembly open because we're now going to put it into a tool. So let's go to Tool Structure, and let's select this tool template, and give it a file name of Tool ASSY. It's going to automatically put the project name on it. On every component that goes into the tool now at this point, it automatically mates the tool, as you can see there. And now we're going to adjust the size of the tool over here. Let's make it 25 inches or so. Nope, 24. That's better. And don't worry about the Control Q, the guidepost, all that updates itself. It's not a problem. And now let's cut some punches. We'll start with that. So, punch mounting. Actually, you know what? I'm going to do one more thing. I'm going to edit. I'm going to open the strip assembly. And one other thing I wanted to do is show you this other over here. We can do this when we're in the strip or not. Let's put a heel on this punch. We've got lots of different flavors. We can put the rooftop shear at the same time. But let's just do this. And we can change this again right now very, very quickly. I won't for the sake of time. And then let's also put a shoulder, or a pedestal I should say, on this punch. And let's change that one. Okay. And save that. And Control Tab to go back to my tool. And now let's mount some punches. And let's mount this one, and this one, and this one. And it remembers the last numbers that we used at any given time. If we select the punch plate, it automatically selects the plate under it. So you could put 5/10 clearance on there if we like. The stripper plate, let's make that only 10 thousandths clearance. 0.004. And that's good. And hit OK to that. Okay, and we just cut the cavities for these punches with the proper clearances. Okay, now let's, I think the next thing I want to show you, again, because we've only got a limited amount of time, I'm going to show you our add and insert command. Let's hide, whoops, I am showing that already. Let's hide the strip. Our filters are very nice, very, very fast. Hide the, no, I don't want to hide. Edit the part, create a sketch here. Nice LogoPress command, zoom normal to without zooming out. For those of you that know SolidWorks, you know that would be nice to have. And let's draw a rotated rectangle, a center point, 3-point rectangle. Okay. And now let's put some chamfers on there, 0.125, here, and here, and here. And the last one we'll leave sharp for now, and I'll show you why later. Okay, so we just created this sketch in the die plate, and once we've done that, we highlight the sketch, and then we simply go up to add an insert. And we can do throughout or blind. If we want this removable in the press, 0005, M2, we can change the material thickness. Let's put a shim under this automatically, a 0.25 thick shim. And let's put 0.0 10 thousandths clearance on the shim and hit OK. Click yes if you want to edit the plate. Yes, I do want to edit that. Thanks for letting me know. And now we want to use LogoPress 3 Sketch Fillet Management down here. Really nice. And let's start by changing a chamfer to a fillet. We've got a bunch of settings that are very, very easily customizable. And let's change that one and that one and that one. And then let's do a round mismatch in this corner. That's what we just did. Okay, and okay. And let's zoom previous, and look what we've got. And now if I open this part, it's a totally separate part. And if we look at the properties of it, there's the material heat treat, etc. Okay, and let's put some components in, standard components, screws, change to generic inch, and change to a 1/2-13, and click here, and hit OK, and automatically pattern, and hit OK, and OK. And let's show the upper, and let's put in some standard components, and let's put in some nitrogen cylinders. The base space, we've got lots of different nitrogen cylinders to choose from. We'll go with Dadco's, and the base space is here, and the length plate is here. Other plates crossing through are here, and let's look at this from the front so we can see it nicely. And let's change to 0.47 travel. And on the length plate, I don't want that to be 125 deep. I want it to be 0. Also create the clamping screws, please. And OK. And now we can manually put the screws in there or the cylinders, and this is showing us where the center of tonnage is. And you saw the nice preview that we have so we can work around punches and stuff. And there's the clamping screws as well. LogoPress three standard components, different types of pad retainers. Let's put in a reverse style pad retainer, again, different brands, etc. Let's put in a lamina with flats. Length plate is here. Other plates we're crossing through are this one. And let's put 0.5 travel on that. And hit OK. And automatic pattern. And OK, and OK. And quickly after a design review, somebody realizes that we didn't leave sharpening room on these screws. So I can just hit this, and I could change them to flatheads if I wanted. I could change them to a different size in just moments. But all we want to do is change the depth, right? So we'll zoom in on that so we can see what's going on. And so we'll change this to 0.875, so we've got grinding life, and watch what happens to the length of the screw. And on the tap tool side, we don't want to blow the chips out of there, so let's just go through with them. Our standard component library is one of our absolute really strong spots. The whole product is really great, I think, and our customers, I believe, would agree. Save that. But the standard components are very, very strong. And generic inch dowel pin, press fit here and here, and hit OK. And automatic pattern. Again, I can take it from whichever place I want. It remembers the last thing you did. So we don't want 4 points, we want 2. And we want this to be 1.75, like so, and hit OK. And now we're in SolidWorks sketch mode, so we can foolproof one of them right here. Okay, and finally, let's show the whole tool. Let's show our strip. And let's quickly show you some tool animation. Actually, first I should mount some punches. I'm going to mount punch mounting. I didn't finish that other punch yet. I'm going to do that first quick. So this one, I'm going to edit that, and we'll do a moved, whoops. Click here and do move base, and let's make that 0.2, and hit OK. And then click here and do a sketch and convert entities. Oops. Click here. Oh, we do have a sketch. Convert entities. I think I did offset entities. Hit OK. And pause extrude. Excuse me, but we're going pretty fast. Hard to keep up. And then take this and create a rectangle on there about like so. And again, I won't bother dimensioning. But it's good that we've made some little mistakes here and there because it shows you how we handle them. And then we'll do a cut extrude on that. Whoops. Did I lose that sketch? There we go. Cut extrude using that sketch. Through all and OK. And now we're going to mount some punches quick. Punch mounting, this one, and this one, and this one, and this one, and this one. Oops, I deselected that. There, we'll mount those. Punch plate is here, and we'll say there's no punch retainer. So just mounting those form punches for now. Obviously, this isn't how you would do it in the die, but it helps to show you the animation by doing this. Okay, so those have been mounted. The other ones that aren't mounted yet, I'm simply going to hide those in the strip. And hide, and save, and go to tool animation. And this is all the setup that's required for tool animation. I like to show my lines. This is the setup. You type these three numbers: 3-inch travel, 0.5 stroke, and 0.4, let's say, lift, and then we hit play. I like to speed it up a little bit. And we can zoom, as you can see. So very, very robust. So that's as much as we have time for from a tool demonstration standpoint. I wish I could show you more. But with that, Brad, I will let you take it away.
Very good. Thank you, Ray. Excellent demonstration.
Thank you so
much. A lot of neat little features. At this point, we'll go ahead and welcome our guest from TrueLine. We've got Terry Trueblood, who is the company's president, and joining Terry we have Dale Christofferson, who's director of tooling. Welcome, gentlemen. Terry, why don't you go ahead and tell us a little bit about TrueLine and what the company does, and then we'll talk a little bit about how you're using LogoPress 3.
Okay. TrueLine was started by my father back in 1963 as a job shop, tool and die job shop. In the early 70s, he also started building automated special machines. By the late 70s, we started contract stamping. In 93, he retired, and I bought the company from him, and in 09, we added the injection molding. And that's about enough on that. We don't have a lot of time, right?
Yep, well, that's true. So tell us about die design then. When did you start using LogoPress 3? And I understand that you had another 3D program in place. Tell us about the difference between the two.
Right. Well, real quickly, of course, we did 2D design first, used like an AutoCAD, and then we went to 3D software package in, I think, October of 05, and we just struggled with it, and it couldn't handle the size of our tools, you know, the amount of components and stuff. We just had a lot of trouble. So then we switched to LogoPress, towards the end of the year in 07, and we've been happy with that ever since.
How many seats do you have of LogoPress 3?
Oh, gee. I lose track. Dale, why don't you answer that?
Well, today we have 6 seats of SolidWorks and also have 6 seats of LogoPress. And back when we were first kind of exploring the option of looking into LogoPress 3, we were a little bit skeptical, a little leery of, because we'd already spent a lot of money and training and especially all the time on another software without really getting the results that TrueLine was looking for. So we went into it quite cautiously. So we took 2 of our designers here and we sent them to training, LogoPress training. And then when they got back, we took one of them and we just had them start designing in LogoPress while the other designers stayed in our old software. And having had a couple years of experience in the old software, we had a pretty good baseline of what we could do there. So what we were really looking for is, you know, a way to compare one versus the other to see which one would give us the best results. And after several months and several projects of using the LogoPress 3 and comparing it to the other, we started to see that LogoPress 3 was coming out on top. It was giving us better results, making less mistakes, and so on and so forth. So at that point, we bought some more seats and started to convert all of our other seats to LogoPress. The LogoPress 3 just seemed a lot simpler to learn and a lot more stable. You know, it kind of breaks the design down into little smaller pieces, a little bit more manageable for the designer to keep track of. Mm-hmm. So, and another real advantage we've seen is bringing new designers into it. If they had a pretty good SolidWorks background, we could get them into it and they'd take off pretty much right away, even before training. Mm-hmm. And so we were real comfortable moving ahead, and hence we got up to 6 seats.
Can you speak a little bit more specifically then about what you had hoped to gain in functionality when you switched to LogoPress 3?
Well, the reason we were making the change initially to go from 2D design to 3D design, we were looking for a couple of things. One was to cut down on our design time. The other was to give us greater visual detail in our designs and to make less mistakes and generally just speed up the building process of the whole die all the way through the process. Mm-hmm. And having had our first 3D program for 2 years and not really realizing, the goals that we were really looking for, that's what really prompted us to go to LogoPress 3 and explore that. One of the large problems that we experienced in our original software was a lot of missing holes or having a plate, 2 mating plates, one plate having like a 3/8 counter bore in it, the second plate having a 5/16 tap in it, and of course that didn't line up very good. And because of the way our process works here, kind of an assembly line type process, a lot of times them mistakes would never be caught until we were putting the assembly together, which caused us a lot of rework, or in some cases we had to make the parts over, which really disrupted our flow of getting all of our projects done. And we're very busy, so we have a lot of machines. We got 7 wire machines that we run upwards of 80% uptime, and to remake things or make things over, that really puts a hurt on us. So, just in short, we're really looking to make it faster.
Right.
Make the whole process, building the tool, whether it was design, assembly, everything, a lot faster.
Right. What's the learning curve like? What was it like for you all when you made that move from 2D to 3D?
Well, it was quite a struggle in the beginning. Having designed several years and everyone here using 2D AutoCAD, one of the big areas was our computers. We just did not have the computers with enough RAM, large enough video cards, and our whole system really beefy enough to handle a 3D package. And we have an IT company that we use for support at times, and as we kind of reached out to them, most of their experience was always in office software, some type of data management, so they didn't really know, they weren't a lot of help to us. They didn't know exactly what to give us. So it took us several computers, several configurations of computers to really get something that would run it effectively. Mm-hmm. And Ray and his group there was pretty instrumental in helping us, putting us onto the right kind of computers and hooking us up with the right company to help us solve that problem. Another large problem was, the software, getting it, the learning curve, getting people up to speed on it, and then we had a lot of inconsistencies, and we had a hard time determining if that was really us, we were doing something wrong, or if the software was doing something wrong. So it really made us, we weren't sure, we spent a lot of time. And so in short, at the end there, the TrueLine, we kind of look at a computer a lot like we look at a machining center or a wire machine. Faster the computer, faster the designer. Yep. So we spend a lot of time on that. And now I'd say we're roughly designing dies with greater detail at about 70% of the time that it used to take us in 2D, and making a lot less mistakes. And that tool that Ray showed at the end of his simulation there, using the interference detection and the simulation, that really is a helpful tool to keep you from missing clearances and so on and so forth. And the other thing that it really helps down the line, because you have so much more visual to look at, and people are using the solid model. to program off from, whether it's the wire or the machining center versus using 2D prints that need to be converted.
Okay, great. Any other comments before we wrap up and take some Q&A?
I'd just like to jump in one quick thing, Brad. I apologize. I had said that we were going to have a case study for Technique Incorporated. It's a prototype tool company that has our LogoPress 3F software, and I didn't have a chance to get that done, so I didn't want to do it halfway. So we'll be getting that on our website within the next couple of weeks, so make sure and watch for it.
Very good. Okay, we've got a few minutes maybe. If people in the audience want to pose some questions for Ray or for Terry and Dale, please go ahead and fire away. We'll wait a couple minutes here and see what we've got. I've got no questions pending, so first come, first served.
Hopefully that's a good thing. Maybe we answered all the questions already.
I don't know. Well, here's one. Let's see what we got here.
Here's our contact information, too, for those that you can contact us at our a number of email addresses, actually.
Right. Ray or maybe one of the guys at Trueline want to address how much RAM is really needed to run the software effectively.
I'll jump out there. 8 gig of RAM is typically enough, but RAM is incredibly inexpensive today, so 16 gig is, it's almost silly just not to do that. But 8 is adequate for the 90% of the people out there.
Tell us a little about how it handles detailed drawings, Ray.
Drawings, we've got 2 different methods of automatic drawing creation, and it's too much to explain quickly. But again, we've got our own LogoPress 3 hole charts that really enhance the SolidWorks hole charts, as well as our own LogoPress 3 bill of materials. And as you saw with the previous slide, the SolidWorks Gold integration, we're the first company that has ever not had any changes. So we're integrated very well. So anyway, the drawings, feel free to contact us and we'll give you a lot more detail on that.
Okay. At least one of the attendees missed some of the demo. He's asking that we redo it, but I would say in the interest of time we don't redo the demos, but to let everyone know that, as I said earlier, that the webinar is completely archived and will be on our website within the next day or two. Everyone that registered for the webinar will receive via email a link to view that archive, and you'll be able to see the entire webinar from its beginning. So I guess the guys at Trueline, what kind of computer equipment did you wind up buying, and I guess if you want to tell us how much you invested in hardware?
Most of ours all have 8 gig of RAM. It's also important that you have a really nice video card.
If I could jump in, Dale, I guess I had helped them spec out most of those computers. So a key thing is which components are going into them, not just the video card, not just the chip. You always know that part. But unfortunately, with some of the larger manufacturers, you have no idea about the motherboard, and you have no idea about the specifics of the hard drive and the power supply, another huge thing. But the bottom line is a great computer, what Trueline was buying a couple years ago for $6,000 or $6,500. They're awesome computers. Most of what we spec out today is around $3,500. But again, that's got to be a certain computer with certain hardware in it. Don't just go spend $3,500 and think that that's what you need.
Yeah, one of the questions I think delves into that a little bit more deeply in terms of the graphics card. What type of graphics card do you need to really show smooth transitions?
Okay, that's an easy one. I hate to talk about everybody in the SolidWorks community, or a lot of people. There are both ATI certified cards out there and NVIDIA cards. The vast majority of people are getting NVIDIA cards, and an NVIDIA Quadro 2000 or 4000, preferably the 4000, is an excellent card.
Ray, was that part shown in the stock strip completely flattened with LogoPress, or did you need to use some other software to assist?
No, it was completely flattened with LogoPress.
Right, that's what I figured. Can data be downloaded to the wire machine directly?
I guess I think that gets more into the CAM end of things.
Right.
And yeah, I guess we're not really involved with that part. It would get into CAM software.
Okay. How hard is it to modify a flat blank after real-world development?
Great question. I'd really encourage users to go to our website at accurateDieDesign.com. Phenomenal question. In the upper right-hand corner, you will see a link saying knowledge base. It's also highlighted on our website. And go to our knowledge base and just type in the search field development or develop or something like that. Or under the categories, there are two categories that both have all capital letters with important tips for LogoPress 3 users. Click on those because there's just a couple of tips, and it'll show you. And it looks like there's a lot of information there as far as how to update. But if you follow that, and once you've done it twice, you know how to do it. But when you follow that, it goes very, very smoothly. But it needs to be followed.
A couple more questions here, and then we're going to have to take this offline. Does the program do deep drawing?
We do. We've got a very specific round draw module, and I'm sure on the emails that were sent out, the round drawn part that was there, it's got weld dimples on it and lances, etc. So we do absolutely an incredible job with round draws, but we don't have any special software, if you will, for rectangular shapes or odd shapes, other than for flattening parts. And then when you get into really deep draws, you really should be using the forming simulation software that we also sell by FTI Forming Technologies. You really need software like that when you get into really deep draws.
Okay. How about handling large castings, like 5.5 by 2.5 meter size castings?
We've got people building absolutely huge dies, so the size really doesn't matter as long as the computer will handle it. So again, the computer is absolutely key.
Okay. All right, this is going to be the last question, and then we'll have I'll make a closing remark for those non-tooling engineers who'd like to utilize the program for its flattening capabilities and ease of creating bent parts without the difficulty and errors of standard SolidWorks. Is there a version of the software that will only assist in bent stamped parts?
Wow, another phenomenal question. Yes, the LogoPress 3F is available as a separate product. LogoPress 3 Unbending, if all you do is linear bends, that's available as a separate product, but all of those are included in the full tool design software, and LogoPress 3 Blank is included in the full product. But the majority of what we sell is the LogoPress 3F for tooling engineers that are doing quoting like that.
Great.
Great question.
Thank you, everybody. I know there might be some questions left unanswered. Ray's email address is on the screen. Obviously, Ray will welcome your email questions to further the conversation. I want to thank everyone once again, and particularly our guests from TrueLine for joining us for today's program. We hope everyone found it to be a very valuable experience. You will be receiving an evaluation form from us to complete and return. Please let us know how the program went from registration right through the actual event. We'd also like to hear back from you about any topics that you'd like us to see us address in future programs. Your feedback, as always, helps us offer relevant programs for the metal forming industry in the most user-friendly way possible. Thanks again to everyone, and have a great afternoon. You may close your browsers now.
Thank you, everyone.